So, we're on to electrochemistry.
Can I borrow paper?
Can you fly?
So we're on to electrochemistry. So clearly what we're going to be doing is we're going to study that branch of chemistry that deals with movement of electrons, production of electricity, voltage, and current. And we just saw a moment ago how just simply putting metals together in the right circumstance can get us a current. So we're going to explain all of these things, hopefully, and explain how this all sort of comes together in this branch of chemistry. It doesn't have much to do with the previous sections of our course, so you can't forget about the equilibrium, because you're going to come back to that when we do acids and bases, but electrochemistry is really a little bit different, so that might be nice if you have a disequilibrium. All right, so we saw that various metals Alright, so what we did was, a moment ago, we combined various metals and we used them to produce a voltage. And our hypothesis was that it had something to do with the metals gaining or losing electrons to become ions, and that had something to do with the voltage. And the theory supports that as well too. What we think is that metals have different affinity for electrons. Some metals like their electrons, and other metals don't like their electrons as much and give them away. Can you think of a common metal where we often see it give away its electrons? We often see it give away its electrons. We seldom see sodium give away its electrons. Why do we seldom see sodium give away its electrons?
Because it's
already given them away, and by the time we meet sodium, it's already an ion. Right? We almost never meet solid sodium. But is there a metal that we do meet in its solid form, and then it gives away its electrons rather frequently?
Silver, copper, and gold.
Well, most of the gold I met already has its electrons because it's already in the solid state. So once again, gold tends to keep its electrons. So already, just by our answers, we're getting some information. See, there's no wrong answers here. We were suggested that sodium might be one of the metals. And it was suggested that gold might be one of the metals. But one thing we know about sodium is when we meet sodium, it's always already an ion. And gold, when I meet gold, it's
always pure.
Yeah, it's already gold. It's in a gold ring or something, and it's already pure gold. So sodium has already given away its electrons. Gold has kept its electrons. What we're looking for is a metal somewhere in the middle, where we see it sometimes with its electrons in the solid state, and sometimes it's given up its electrons and it's in a different state.
Okay.
Yes?
Iron.
Iron is a good one. All right. So iron, we see iron in its solid state bonds, and we see iron having given up its electrons a lot. What is the name we give to a sample of iron that has given up so much of its electrons?
Oh, no, it's rust.
We call it rust. When iron has given up its electrons, we call it rust. A bit more rust than just the iron, but yeah, it's given up its electrons. No longer is it good for a nice shiny object. It's a rusty object. It's a different substance. It's iron giving up its electrons. So, already I can have what's called an activity series. So what we're doing now, in addition to paying attention in class, is we're beginning to look at these metals and we're going to rank them in order of their willingness to release electrons. Now, willingness to release electrons is a little bit of a cumbersome term, so we want a better term for that. Yes? Electronegativity is a good term. It is similar, but electronegativity is actually the opposite.
Conductivity?
The more you gain electrons. But that's not what we're talking about here. We're talking about metals doing the one thing they can do.
Give away.
They can only give electrons away. In fact, that makes the difference between metals and non-metals. So just as a quick review, think of your periodic table. Right? And this section all here is metals, and this section here is the non-metals.
There's a reason why
We usually use electron negativity to talk about non-metals because they tend to
take off.
gain on electrons. Sometimes they give them away, but often they gain electrons, and these are the non-metal parts. All these are the metals. And what is the one thing that a metal does if it goes to react?
Give away an electron.
Give away electrons. It doesn't
Composite.
take electrons, it only gives away electrons. So this is your periodic table. This section here that I've shaded in is where all our metals are. And the one thing that makes a metal is,
Positive ionic state.
yes, it tends to give away its electrons and make a positive ionic state. So they tend to release electrons. So it should be obvious why in the discussion of electrochemistry we started with talking about metals, because we know from our previous work in science what electricity is. It's electrons flowing. You bet we're going to need something that's going to release electrons so that they can flow. This means our discussion is going to be about metals. Right? Because we have to get electrons to get them to flow. Well, what part of the periodic table of all the elements in the known elements in the universe, which ones release electrons to flow? Metals do. That's why we make wires out of steel or copper and now out of bromine. Okay, now we're going to rank these metals in order of their willingness to release electrons. Okay? And we're going to call their willingness to release electrons their oxidation potential.
Oxidation potential.
Copper turns green and oxidizes.
I don't oxidize.
Now, why oxidation potential? Well, we had to pick a name for the release of electrons, and we're just going to call that release of electrons oxidation.
PO.
Okay? Good. So in other words,
Potential.
when we give up electrons, we're going to say the metal is oxidized. And so we've got this term, and we just picked it out of the blue. Well, we didn't really pick it out of the blue. There's a reason we picked it. So the metals we're going to rank, you're going to rank them. In a minute, you're going to rank sodium and copper and iron and gold. And let's just throw calcium in there as well too, so we get something a little bit different. Now you have enough information in your chemical knowledge to rank these. We're not going to rank them just yet. First, we're going to talk about why we have this term oxidation. And the reason we have this term oxidation is it's kind of awkward to say willingness to release electrons. So we'll call the term oxidation, which means willingness or the process of releasing electrons. Yes?
When metals release their electrons, are they oxidized?
Very good. So if we're going to use the term oxidation for release of electrons, then being oxidized means you released your electrons. Good use of terminology. Yes?
So we can assume that oxidation potential, we can assume that the more easily a metal rusts, the higher the oxidation potential.
Sounds like the way to go. So we're saying it has a higher oxidation potential. Alrighty. So to help us remember this, we come up with a little mnemonic.
Leo.
Leo, the lion, says
Yeah.
grrr. And that helps us remember that
Does this make sure Ian is vegan? Like,
Ross
No, it's just we have our history test right now,
Cowspiracy.
which I studied the wrong thing for.
Wait, what? A history test?
Yeah, it's today.
Apparently it's about World War II and not the Cold War.
What happened?
All right, that's all that we had time for today.
Yeah, that's right. How are these?